I want to wrap this up with kind of a why do we care about this sort of stuff? I would say that one just really important application of this is batteries. I mean, where would we be without them, right? In just your regular alkaline batteries, or sort of more complex cell phone batteries, rechargeable ones, there's a anode and a cathode. And in just a regular AA battery like this, your anode is the bottom, the negative terminal, and your electrons are able to move out of the battery to power your device, and they're attracted back to the positive end of the battery. If we break open a battery, what you can see is that in a typical alkaline battery, the anode is zinc, just like in the cell that we were examining in this lesson. And the cathode is a different material, manganese dioxide often. A little more complicated than our voltaic cell with just, two beakers and some wires, but it's a portable source of electricity, which is really important. What I think might be even more interesting to me, at least, though, is how batteries are essentially in the environment. And a lot of electron transfer in the environment involves microorganisms. So I want to take a look at that a little bit. And every organism, whether we're talking about humans or animals or plants or microorganisms, really needs four things: energy source, electron donor and acceptor to be able to harness energy, and a carbon source. So this is not going to be in the final, don't worry. Just kind of an example of cellular respiration. And not going to go through all the details on here, but many, if not all of the reactions that are shown on this diagram of cellular respiration and the citric acid cycle and the Krebs cycle, many of these reactions are redox reactions. And cellular respiration is how we harness energy for our bodies and other organisms as well. Quote from this article: cellular respiration is an exothermic redox reaction, and the overall reaction is many smaller ones, many of which are redox reactions themselves. So humans, other animals, we all use redox chemistry to take energy and to use energy. But, we're pretty predictable. So we eat carbon, plants, meats, things that can be broken down into sugars. Humans and all other animals breathe oxygen, and we exhale carbon dioxide as waste. So that's actually fairly uniform redox chemistry. Microorganisms, bacteria, on the other hand, they exhibit a huge amount of diversity when it comes to sort of their redox chemistry. This is a table of the electron acceptors that a number of different classes of microorganisms utilize. So some microorganisms use aerobic respiration like we do, where they are essentially breathing oxygen. But all these other guys that are on here, and a few more that I added on from my own research and background, other microorganisms are essentially breathing, and yeah, they don't have lungs, so I'm using that term loosely, but they're breathing things like nitrate, sulfate, carbon dioxide, and even iron and uranium. Now that's really pretty cool. The reason why I say that they're breathing these things is because the electron acceptor that we use is oxygen. That's what we breathe. And that oxygen could also be considered an oxidizing agent. It's what's allowing us to break down all those sugars and carbohydrates and things that we eat. And so, yeah, microorganisms, they're essentially, Geobacter, for example, can breathe oxidized uranium and oxidized iron. So the reason why I know a bit about this, and I'm really not a microbiologist by any means, but I was looking at the chemistry of a uranium-contaminated site in Colorado, where our research team essentially dug some wells and injected a carbon source, acetate, into the aquifer where there was some uranium residual from a uranium milling operation. And the reason why we did this was to stimulate the bacteria that could then breathe in that U6, which is a very mobile, soluble form of uranium, and reduce it to U4, which is insoluble in the mineral form of uraninite. So I'm not going to get into too much detail here on the last day of class, but its redox chemistry goes a long way. Just the way that plants, animals, and microbes use it to harness energy and how we can then utilize what microbes are doing for our benefit. Really interesting stuff. This just barely scratches the surface, but yeah, hope you enjoyed it.